Okay, I got cut off on the last video before. I wanted to make the point that I could have checked this work by doing it on my own. So remember to find the expected value, and let me write that here just so you remember. Expected value, which is the mean, right, of random variables. So to find the expected value, I took each value up here for x, and I multiplied it by the probability. Once I add them all together, I get the mean of 11.95. Now, there is a step that you notice that is not happening when you typically average things, right? Normally what I would do is I would add 1, 5, 7, 10, 15, and 25, and I would divide it by 6 because there's 6 numbers, right? And that would give me the average. That's what's different about random variables. We have probability distributions, meaning they're not as equally likely. So I don't divide by 6 because dividing by 6 would say that each of these numbers were equally likely to occur, but they're not, right? 1 has a smaller probability than 5. 10 has a smaller probability than 1. So I don't need to divide by 6 because multiplying by the probability does that work for me. All right, now let's get to the business of adding or subtracting by a constant. All right. So, I want to give our employees a raise, you guys a raise. So what raise should be given? We're going to complete the tables below and calculate the new mean and standard deviation using the calculator. So here's my first idea for a raise. I'm going to add $10 per hour to every employee. All right, so my old wage was 1, 5, 7, 10, 15, and 25. And my probability with those numbers was 0.15, 0.25, 0.15, 0.05, 0.1, and 0.3. Now remember, I just made these up. We were going to do an activity in class where I actually handed out different bills, and then we were going to calculate the probability by seeing how many people got a 7 and dividing that by the number of people in the class. So we were going to actually create these probabilities, but since we're not in class, I just made up these numbers. But it's a valid probability distribution because they all add up to 1, right? Okay. So here are our probabilities with all the old wages. Now let's calculate the new wage based on our option 1 idea, add $10. So my $1 wage becomes 11, my 5 becomes 15, my 7 becomes 17, my 10 becomes 20, my 15 becomes 25, and my 25 becomes 35. All I did was add $10 to each one. All right, now what I want you to do is use these two right here to calculate your new mean and standard deviation. Your new wage is your L1 and your probability is still your L2. So go ahead and take a second in your calculator to update the L1. The L2 will be the same. You just need to update the numbers in the L1. So go ahead and do that and write down your mean and standard deviation. All right, I'm going to show you what I did in my calculator app, even though it'll look a little different than your calculator. So my L2 frequency list stayed the same. I just changed my L1 to reflect the new wage. So number 1 is 11, number 2 is 15, 17, and so on. After that, I hit Stat, went over to Calc, and hit the first option, one variable statistics. And I need to make sure my L2 is my frequency list. And when I hit Enter, I get the new mean and standard deviation. So my new mean is, if this will ever focus, will it focus? There we go. 21.95, and oh my gosh, this thing. My new standard deviation is 9.27. So if we look back at that first example, and I went ahead and wrote it down here. If we look back at the first example, my expected value of my mean was 11.95, and now it's 21.95. All I did was I added 10 too, just like I did to all the wages. My standard deviation did not change. All right, so adding a constant changes the mean. You add 10. Does not change standard deviation. That stays the same. Now let's think back when we were reviewing the Unit 1 stuff about the transforming data. That was the same thing, right? Adding or subtracting a constant. It changed the measure of center, right? But it did not change the measure of spread. The mean is a measure of center, the expected value, and the standard deviation is a measure of spread. So it falls in line with our transforming data. All right, now option 2 is to double everybody's wages. So double means multiply. So all I'm going to do is multiply all these numbers by 2. So 1 becomes 2, 5 becomes 10, 7 becomes 14, 10 becomes 20, 15 becomes 30, and 25 becomes 50. My probabilities don't change, right? It was just the wage. So I'm going to put the same probability as above that I have been using. 0.15, 0.25, 0.15, 0.05, 0.10, and 0.30. All right? Use your calculator again to calculate the new mean and standard deviation. Again, you're leaving L2 exactly the same. Your frequency doesn't change. It's the L1, your wages change. So I'll give you a minute to go ahead and put that in the calculator. Pause the video and see if you get it correct. All right. So you should have gotten an X bar or an expected value, E of X, of 23.9 and a standard deviation of 18.54. Remember, you did this by stat, enter, you changed all your L1 numbers, you left L2 the same, you went to stat over to calc, and you did the first option. You made sure L1 was your first list and L2 was your second list, and then you hit calculate. All right, now let's look and compare this to the original data. So originally, my expected value was 11.95. So 11.95 times 2, right, because we just doubled everything, would give us 23.9, which is what we have. All right, and then our standard deviation was originally 9.27. Let's multiply that by 2 and see what we get. So 9.27 times 2 gives me 18.54. So essentially what I could have done is just, knowing that I doubled every number, I could have multiplied the expected value by 2 and multiplied the standard deviation by 2. So how does multiplying by a constant affect the mean and standard deviation? Mean and standard deviation are both multiplied by the constant as well. All right. Now here's a question for you. Which option would you prefer? Would you prefer for me to add $10 to everybody's wage or double the amount of everybody's wage? Well, let's see. You could look to the expected value, right? So your expected value here is $21, and your expected value down here with the doubling is 23.9. But also look how spread out the data is. In option 1, where the mean is a little bit lower, your standard deviation is $9.27, right? So for the most part, 68% of the data is within one standard deviation of this mean, $9, versus look how spread out this data is. So it could be very variable. You could make much lower than $23 or much higher. So I guess it just depends on how risk averse you are about what option you prefer. All right, so let's do a quick review. Transforming probability distributions of random variables, not just data. So adding or subtracting a constant. That was our first option by adding 10 to everybody's wages. So we know with measures of center, you add or subtract to the measure of center. So it changes. Measure of spread, though, no change. Remember, my standard deviation did not change. All right. And then if I'm multiplying or dividing, which was when I doubled the wages, I multiply or divide the measure of spread. I'm sorry, measure of center. So this changes. And then I also multiply or divide the measure of spread or measure of variability. They're the same thing. So this also changes. So I have change, 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 no change. And then remember, the shape of the distribution is not going to change. So if there's a question that tells you, oh, we multiplied every single random variable by 10, is the distribution still symmetric? Yes. The shape of the distribution does not change. All right, so let's compare that to our original data that we did on the very first page. Changes, 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 changes. No change, change, no change, no change. They're exactly the same. So if you know how to transform data from Unit 1, then you know how to transform random variables in this unit. So it's nothing new here. You're doing exactly the same thing as we did in Unit 1. Let's do some practice with transforming random variables. Now what I want you to do is pause the video and try example 1 on your own, A, B, C, and D. Just try it. The worst that can happen is that you get it wrong and you use your eraser or your whiteout to fix it. I want you guys to practice because this is the time to make mistakes, right? Not on the test or on the AP exam. So do your best, and that way it'll give you an idea of where the misconceptions are coming from if you at least try it before I try it. All right, so pause the video. All right, welcome back. Hopefully you've tried it. All right, example 1. How much does college cost? ATL Community College considers students to be full-time if they're taking between 12 and 18 units. The number of units X that a randomly selected ATL Community College full-time student has the following distributions. So it goes from 12 to 18 because that's the range of full-time, right? It can't be below 12 and it can't be above 18. Now here's our probability distribution. Now to check that it's accurate, I see that all of the numbers are between 0 and 1, and when I add them up, they should be equal to 1, right? Okay, below is a histogram of this probability distribution. Now my mean, my mu of x, is 14.65, my expected value. That looks about right, looking at the numbers, right? And the standard deviation is 2.056 units. At ATL Community College, the tuition for full-time students is $50 per unit. So 50 times the number of units you're taking. So what transformation occurs to the probability distribution to calculate tuition? You are multiplying by 50. Remember, transforming is just adding, subtracting, multiplying, or dividing the number by each number by the same constant, right? So I'd be multiplying all of these number of units by 50 to calculate their tuition. So what shape does the probability distribution T have? So T stands for tuition, right? I don't care about units anymore. I want to know what the probability distribution of their tuition would look like. It would look exactly the same as this. Remember, tuition or shape does not change. So the shape of the probability distribution I shouldn't have written that right there. Distribution T is roughly symmetric and the same as the distribution of units, which was our original distribution. Right? It looks exactly the same as this. All right, find the mean of T. And calculate the standard deviation of T. All right, so what we're going to do here is calculate our new L1, right, our tuition up here. And to do that, I'm just going to multiply everything by 50. Alright, so I'm going to pause the video while I multiply everything by 50, and then I'm going to put it in the calculator to get the expected value and the standard deviation. Remember, I'm going to put in tuition as my L1 and probability as my L2. So go ahead and do that as well. Okay, so when I multiplied all of the number of units by 50, I got 600, 650, 700, 750, 800, 850, 900. So I put tuition in my L1 and I put probability in my L2, and these were the numbers I got. So to find the mean of T, my expected value of T, my mean was 732.50. That was my X bar in the calculator. And my standard deviation of T was 102.8. So again, I just did that by putting the tuition I calculated in L1 and the probability in L2, and when I go over to calc, I hit the